Good afternoon to my beloved lecturers. My name is Hariputhiran Kannan. Entry number is DE210008. My supervisor name is Professor Madhya Dr. Nabiha. My final year project title is FPGA-based implementation of MPPT fuzzy logic controller for PV systems. And today I'm gonna present about my project. My project introduction is this project presents the design and implementation of a hardware software co-designed fuzzy logic based maximum power point tracking controller for photovoltaic system using an FPGA platform. The MPPT algorithm is implemented in RTL hardware for deterministic performance, while system supervision and parameter monitoring are handled by a NIOS-2 softcore processor. The objective of this project are to design and simulate a fuzzy logic based MPPT controller, to implement the fuzzy logic MPPT controller on an FPGA platform and validate its real time performance, to evaluate the performance of the FPGA based fuzzy MPPT system by measuring tracking efficiency, observing steady state oscillations around MPP, response time to reach MPP, and maximum power. This is the top level hardware software code design that I developed in this project. The top level system consists of fuzzy MPPT RTL and NIOS-2 softcore processor. The platform designer system interconnects all the system components into a unified hardware software architecture. Communication between the software and hardware domains is achieved through a memory mapped Avalon interface. This is the fuzzy MPPT RTL that I developed in this project. This RTL consists of 12 individual modules to perform the fuzzy logic algorithm for the MPPT controller. The fuzzification process are including input calculation, fuzzification, rule evaluation, and defuzzification is realized as modular hardware blocks to ensure low latency and predictable timing. Other modules are implemented in the design to advocate with the fuzzy logic algorithm. An Avalon wrapper module is developed to communicate between the software and hardware domains. It is achieved through a memory map Avalon interface, allowing the processor to write input samples and read back control outputs and also internal status informations. This is the NIOS-2 softcore processor that I developed in this project. The NIOS-2 processor is responsible for system level tasks such as photovoltaic panel modeling, boost converter modeling, voltage and current sample generation, and user interface handling. These functions are implemented in software due to their algorithmic complexity, ease of modification, and suitability for sequential execution. The NIOS-2 monitors data through memory map Avalon interface, enabling seamless hardware-software co-design and real-time interaction with the fuzzy MPPT RTL core. The NIOS processor includes a PV model, timers, hold registers, and UI handling. This is the methodology flowchart for my project. It represents the closed loop simulation. The simulation starts from initialization nearest to main loop. From that, the timer ISR will be triggered every 1 millisecond. It checks whether the irradiance change or not. If it does, it will update the irradiance value. Then it will treat the duty cycle from the RTL. The duty cycle value will be given into the software domain to calculate voltage value from boost modeling equation. The calculated voltage value will be used in PV modeling to calculate the current value. The voltage and current value will be ADC scale and written into fuzzy MPPT RTL, where the fuzzy logic algorithm is processing. The output of the fuzzy MPPT RTL duty cycle value will be written back to the software domain to read back the duty cycle and to update the voltage and current values. This cycle goes on loop. Parallelly, in the software domain, a convergence check will be processing. It will calculate power value from the voltage from the calculated voltage and current value, and it will check whether the power is stable for 10 millisecond, which is 10 clock cycle or not. If it yes, the software domain will verify the maximum power point is reached, and it will continue tracking and maintain the maximum power point. This process continue loop back to timer ISR, which enters every 1 milliseconds. Thank you.